If you look at almost any electronic device, from lights to computers, you'll see switches labeled with 1 and 0. But have you ever wondered why these symbols are used instead of words like on and off? The 1 and 0 come from the world of binary, the fundamental language of electronics and computers. In binary, 1 represents an active state, or on, while 0 represents an inactive state, or off. This simple system allows electronic devices to process, store, and transmit information efficiently. Understanding why switches use 1 and 0 gives insight into the principles of electronics, digital logic, and computer design. In this video, we'll explore the history, logic, and science behind these symbols and how they make modern technology work. The use of 1 and 0 in electronics originates from the binary number system, which was formalized by the mathematician Gottfried Wilhelm Leibniz in the 17th century. Binary is a base 2 numbering system that uses only 2 digits, 0 and 1. In electronics, these digits correspond naturally to 2 physical states, off and on, or no voltage and voltage. Early electrical engineers realized that using just 2-state simplified circuits, reduced errors, and allowed reliable signal transmission. Mechanical switches, relays, and later transistors could easily represent these 2 states, making binary the natural choice for digital systems. Over time, the 1 and 0 notation became standard, forming the basis of all modern computing and digital electronics. Today, everything from a light switch to a supercomputer operates using this simple but powerful binary logic. This simplicity allows electronics to perform complex calculations quickly and reliably. Digital signals based on 1s and 0s are less prone to noise and distortion, ensuring accurate data transmission. Even modern microprocessors, memory chips, and network devices use millions of binary switches simultaneously. The binary system also makes it easier to design logic gates, which are the building blocks of digital circuits. Ultimately, 1 and 0 are the universal language that allows all digital technology to function efficiently. Switches are the simplest way to represent binary states in electronics. When a switch is in the 1 position, it completes an electrical circuit, allowing current to flow, which corresponds to an on or active state. Conversely, when the switch is in the 0 position, the circuit is open, stopping the current and representing an off or inactive state. This binary representation is extremely reliable because there are only 2 possibilities, reducing the chance of errors or misread signals. In digital devices, physical switches are often replaced by transistors, which act as electronic switches that can turn on or off thousands of times per second. The principle remains the same: 1 indicates voltage is present, and 0 indicates no voltage. By combining many of these binary switches, devices can perform complex tasks, store data, and process instructions, forming the foundation of modern electronics and computing. Even complex microprocessors rely on millions of tiny binary switches working together. Understanding this simple on-off principle helps explain how all digital devices operate seamlessly. Binary logic is the backbone of modern electronics, and the 1s and 0s from switches allow devices to perform complex operations. Logic gates, built from transistors acting as switches, combine binary inputs to produce specific outputs, enabling calculations, decision-making, and data processing. For example, an AND gate outputs 1 only if both its inputs are 1, while an OR gate outputs 1 if at least one input is 1. These gates form the foundation of microprocessors, memory chips, and digital circuits, allowing billions of binary switches to work together. Using only two states simplifies design and increases reliability, making digital electronics highly efficient and scalable. From smartphones to computers and home appliances, every modern device relies on binary logic powered by millions of tiny switches. The simplicity of 1 and 0, combined with precise engineering, makes it possible for electronics to perform incredibly complex tasks in fractions of a second. Even digital communication, like sending data over the internet, depends on streams of ones and zeros. Understanding binary logic helps us appreciate how seemingly simple switches create powerful and intelligent machines. The ones and zeros represented by switches are used in countless real-world applications. Simple household devices, like light switches and power buttons, use this binary principle to turn electricity on and off. Computers and smartphones rely on millions of tiny switches inside microchips to perform calculations, store data, and run programs. Network devices use binary signals to send and receive information over the internet, ensuring that digital communication is fast and reliable. Even advanced technologies like robotics, gaming consoles, and autonomous vehicles depend on billions of these binary switches working in precise harmony. These real-world examples show that the simple concept of on and off underpins almost all modern electronics, from everyday gadgets to cutting-edge technology. In summary, the 1 and 0 on switches are more than just symbols, they are the foundation of all digital electronics. The binary system allows devices to represent on and off states reliably, enabling everything from simple household switches to complex microprocessors. By combining millions or even billions of these binary switches, modern electronics can perform calculations, store information, and run sophisticated programs in fractions of a second. Logic gates, circuits, and communication systems all rely on the simplicity and efficiency of binary states. Understanding why switches use 1 and 0 helps us appreciate how powerful and precise digital technology truly is. From the devices in our pockets to the computers driving the internet, binary switches make modern life possible, proving that even the simplest concepts can create extraordinary outcomes.